Hello, everyone. This is Aqsa Kausar. Um, so today's session is on explainable AI in Gcloud, and this is about how about understanding um how to interpret the machine learning's famous black box, right? But before we dive in, a little bit more about myself. So I'm a senior machine learning engineer at Red Buffer. I am also a Google developer expert in machine learning, and I am a tech blogger on Medium. So what we'll discuss in today's session is would start with what is explainability really, why it is important, and where does it really fit in the machine learning workflow. And depending on time, we'll walk through an explainable AI example as well. So with time, we have seen that there have been a lot of advancement in machine learning. We are now building way more complex models than we were about 5, 6, 10 years ago, right? So it started with initially we had rule-based programs, and then we started building linear models and decision trees, and then we moved on to deep learning, deep models and ensembles, and quite recently we've started building meta learning models where you basically have one model that creates another model. So with time, the complexity of the models has increased. And at the same time, this also means that the models have become more opaque and more difficult to uh, for practitioners and researchers to understand. Right? It has become more difficult for to understand why the models are making certain predictions and why they're making the prediction that they're making. Why is the model calling a cat, and why is it calling a dog, and when it's not performing that way. Um, what does the model see that gives us the false prediction signals, right? Um, with more complexity over the years, we have also seen that um, the models have become more expressive. So when I say more expressive, I mean to say that we have a lot of domains that we are covering now. So we have forecasting, we have self-driving cars, and at the same time, the models have become more versatile. So when I say versatility, I basically mean to say that uh, so in the sense of versatile, like there are more data modalities that we have unlocked, right? We're not just dealing with text or speech anymore. We're also dealing with models that take both text and speech, or they take text and vision. So there are combinations of these the data combinations that we have unlocked, and we've also worked on making the models more adaptable. So we have transfer learning now that's widely used, and we can train models that have less data. And we can use transfer learning to basically transfer knowledge from a larger model that was trained on a larger data to smaller models that we want to train with smaller data sets. And there has also been an increase in efficiency. We even have efficient hardware now, for example, TensorFlow TPUs, which are designed to perform well on TensorFlow models. But with all of these, as I said earlier, that the models have become more opaque as well and harder because of the increased complexity. It has become harder to uh, uh, understand how model predictions are really working, how the model is really working inside to give out the predictions that it's giving. And this is exactly where explainability jumps in. Explainability is the ability to explain or to present in understandable terms to a human, right? In simpler terms, what is explainability is that it is the process of understanding how and why a machine learning model is making predictions. Why is it making the predictions that it's making, right? And the same examples, that why is it calling a cat, and why is it calling a dog? What is it really learning that helps it to differentiate between the two? And explainability is important for both model builders and model end users. It is really important for model builders to be able to understand their model behavior, because this would help them improve their model, right, and increase the model performance. And model end users, we have a lot of people who, for example, outsource a problem, and they do not have the technical knowledge of it, but they want to understand how the model is performing and why is it making certain predictions. And it helps them to build trust in that model. So it is also important for model end users and not just model builders. So what does explainability look like for image models? So for example, we have a model, a classification model that classifies different images. And here we can see that we have a bird in the first image. And the second image is what explainability would return to us. So what it returns is that it returns the signal, the pixels of the image that basically signal the most towards the model output. If the model is calling this a bird, which pixels in the image basically contributed the most towards that prediction? So explainable AI would return us an image like this, and we would be able to verify that whether or not the model is looking at the right features for the prediction. For example, if we can see here that it has highlighted the beak, and the general shape of the bird has contributed to the prediction, and this is a correct learning of the model. But for example, if instead of this, the pixels highlighted were pixels in the background, in that case, we would know that the model is learning incorrect features from the image. And it's not, and we can use that as a feedback, and we can use it to basically improve the model, to retrain the model, to gather more data, to understand what things in the background are basically confusing the model in the predictions. And we can use all of that information to build a better model. So what does explainability look like for text models? For text models, for example, we are classifying sentences into different types. And for example, one of those types is action sentence, right? And we can see what explainability would do in this case is would give you pieces of information such as these words that it believes are contributing the most towards the predicted label action. So in this case, we have mission and learns and kill, and these words are contributing the most towards the predicted label, which is the action. And especially in case of natural language processing, it's always very important to be able to understand how the text is contributing to the prediction, because natural language processing is very tricky in that sense that it's harder to understand what pieces of text or what groups of text or what combinations of text in the sentences are contributing to the predictions. At the same time, we can also use this to understand model bias, right? If a model is biased towards a certain group, for example, I have a classification model that classifies sentences into positive and negative sentences. And for example, I have two examples. The first one is I like Liverpool, and the second one is I like FC Barcelona. Now, in this case, Liverpool and FC Barcelona are both called identity term. An identity term in this case shouldn't have a weight. It shouldn't be contributing to the model output. What should be contributing to the model output are words like, right? Are words such as like or love. So in this case, if we would expect that if the model has learned things right, the model should be performing similar on both the sentences. But if there is a massive difference in how the model is performing in both of those sentences, then in that case, we can know that the model is biased towards a certain group. For example, we get positive prediction for I like Liverpool, but we get negative prediction for I like FC Barcelona. So in that case, we would know that the model is negatively biased towards FC Barcelona, the group FC Barcelona, and it's learning from identity terms, but shouldn't be the case. So these things basically help you also in AI fairness, where you are able to see that whether or not your model is performing fairly towards all groups. So coming to tabular models, and so for example, we have a classification, a regression model, which basically uses certain features, for example, maximum temperature, weekday, start hour, etc., and it gives out a prediction for how long the bike ride has been, right? How long did the user ride the bike based on these certain features. So in this case, we can have what explainability returns is a tabular information like this, where it gives out feature importance levels. So we can see that maximum temperature has a negative attribution value of negative 2.5. And we can see that temperature has it of negative 0.4, starter has it of negative 0.6. And what this does is that it gives an information that maximum temperature negatively affects the time duration of the bike ride. So as the maximum temperature increases, the duration of the bike ride generally decreases in the data set and in the prediction of the models. So this is how the explainability basically works for tabular data. So why is explainability important to model and users? So especially in case of medical images and applying artificial intelligence, machine learning in medical cases, it is very important that doctors are able to trust that system, right? And for example, we have on the top left, we can see a retina image, and a data set of retina images was used for classification of the risk level. Diabetic retinopathy is basically a disease that can be diagnosed using retina images. So we can use a data set of retina images to basically build a classification model that would tell us the level of diabetic retinopathy in the patient. Right? It could be weak, it could be low, it could be mild risk level, it could be high risk level, and in that case, it's not just giving an input image and getting an output from the model matters, but what also matters is that the doctor would want to know that why did this model predict mild risk level for an image, or low risk level for an image, or a high risk level for an image. And this is how the doctors would be able to build trust with that model, right, before it goes out completely into production. And here we can see that in this image, the predicted label is mild risk level. And we can see that Explainable AI has highlighted these regions, these pixels, that have caused it, that have signaled toward the model prediction being mild risk level. And this can basically help in a lot of other cases as well, and not just medical, but wherever it is vital for the model and users to understand why the model is making a certain prediction, and wherever in cases that it is important that the model is verified in such way, then it becomes important. Explainable AI plays a vital role there. It can also be used in cases, for example, when you're getting movie recommendations, to tell you which previous movies that you have watched basically led to the current movie suggestion. Why is explainability important? So normally, accuracy is a pretty good measure of evaluation, right? When we have high accuracy, we tend to say that the model is performing really well. And we have low accuracy, we tend to say that the model is not performing so well. But accuracy is only one piece of model evaluation. For example, there was a data set of X-rays that was used, and a model was trained for diagnosis using those X-ray images, and the model performed really well. Right, you had like accuracy in 90s, and the model was performing really well. But when they went deep down to see how the model is performing this well, why is it making the predictions that it's making, they were able to debug that the model is not just looking at the X-ray images, but what the model is doing is that it's learning from the doctor annotations on those X-ray images. So it's not learning and the right features, even though it is giving very high accuracy, but the performance of the model and the behavior of the model is still buggy, and because it's learning from the wrong features in the images. So these kinds of bugs and these kinds of flaws and loopholes in a model, these can be picked out using explainability. So having a summary here of why explainability is important. For model builders, it is important to identify bias in the model's behavior, to understand how the data set influences model output, what features in images contribute the most towards the model predictions, what features are the most important in tabular data, which features are negatively or positively increasing or decreasing basically the model output predictions in tabular data, which words are influencing the model predictions the most in text data. And all of these things basically would help you to understand your model behavior, and the information that you understand and the knowledge that you get from that can be used to improve model performance. So for model end users, it becomes important because it helps the users to explain why an individual data point received a particular prediction. And that's basically what the model users are concerned with. They're not concerned with the technical background of that application or that system, but what they are concerned with is what they're seeing as the output, the relevance of that, the confidence in that output, um, uh, basically verifying that output of whether or not it's the right output, whether or not it's learning the right things, whether or not it's the model is pointing towards the right things in text, image, tabular data. And all of this basically helps the end model end users to understand model behavior as a whole and to build more trust in the system. And this becomes especially important when you're dealing with clients and your clients don't want to just know what output the model is giving, but they also want to understand model behavior as a whole and to understand how the model is learning. And it becomes critical in that area as well. So the basic machine learning cycle basically starts with you gather and you pre-process data, you build model, you run training and evaluation, you deploy that model, you make predictions. And explainability basically doesn't plug into just one area. It, as a whole, it plugs into multiple areas in this life cycle. So it can help you identify dataset imbalances. In explainability, there's also a what if tool, which can be used easily to identify dataset imbalances. It can also help you to ensure your model is treating all groups fairly. So as we saw earlier with the Liverpool and FC Barcelona example, you can use explainability to understand and to see and to verify that your model is treating all groups fairly. And you can also use it to set prediction thresholds. So for example, if I have a classification model for a cats and dogs classifier, then in that case, maybe if the model is 80% confident, then I would like it to say that it's a cat. And in that case, 80% is fine, 80% threshold. But for example, if I am training a model for cancer, right, to diagnose cancer in patients, In that case, I wouldn't just want 80%. I would want the model to be really, really accurate, and I would want good precision in that case. And in that case, because I wouldn't want someone to be misdiagnosed with cancer, right? So these, above 90% or 80%, these are prediction. These can set prediction thresholds for you, and you can adjust these using explainability. Explainability in as a whole, and the most important basically feature of explainability and importance, it lies in understanding model behavior, especially on real data. So when we are training models, we are validating our models. We are using the training data, which is pre-processed, which is clean, and in a lot of cases, when we take that model, it's performing really well on the training data, on the validation side. And when we take it out and we plug that model for the real data, it starts to crash and it starts to perform badly. So we can use explainability to basically understand model behavior on the real data, and to understand how the model is behaving differently for the training data and for the real data. And this would basically help us gain knowledge of what needs to be improved in to help the model perform better on the real data. And then surface prediction analysis to end users, like we've mentioned, that for people who do not have technical knowledge, it helps them gain more confidence in the model by seeing why the model is making certain predictions. And this obviously is not a one-time process, it's an iterative process. So you identify dataset imbalances, you do all of these, you ensure your model is performing fairly, and wherever in this cycle you find flaws in your model, you fix them, and then you reiterate through all of this, right? Now, how can you do this on GCP? So GCP has a lot of features. There are ML APIs, which are pre-trained for models with a single REST API request. There are AutoML, which are train and serve custom models. So no model code is required. These are basically, for example, Google Vision API, Google Natural Language Processing API. All of those come under AutoML. Then we have BigQuery machine learning. We have AI platforms where you can train your models, manage them, train them, serve them, serve those custom models, and all of the other features of GCP. Now, Explainable AI currently is available at 2 of these places in Google Cloud Platform. The first one is AutoML tables. So where you have option for Explainable AI, and you can use Explainable AI to see your model behavior on tabular data. And the second is AI platform. So currently, Explainable AI is available for models that are deployed on AI platform, but TensorFlow models currently, for both TensorFlow 1 and TensorFlow 2, there's it's available for both. It supports both, but currently it only supports TensorFlow models. So coming to how explanations work on AutoML tables. So first, it gives out, you can have like a global attribution values for the model, global feature importance. You can have that. In global feature importance, you can see how the features overall affect the model predictions. For example, in this case, we can see that Euclidean has high feature importance in comparison to the other features. At the same time, there's instance level attribution values for the models. So for instance level, for every single data point, so for the different data points, you can see which features contributed the most towards the model prediction. And which, for example, if we are predicting duration of the bike, which features contributed the most towards the model prediction, but also which features help to increase bike duration and which features decreased bike duration in the predictions, right? So which features positively affected bike duration and which features negatively impacted bike duration. So that you can see from here. So here we can see that this feature had a positive impact, which means that it increase help to increase the bike duration, and then there are features that had a negative impact, because of which the bike duration had there was a negative impact on the bike duration. And as a result of all of these features combined, positive and negative impacts, we got the model prediction output that we got. And this basically helps us to debug model behavior where necessary. Explanations on AI platform. So we can use it to interpret on image, text, and tabular, all three of the models if they are TensorFlow models deployed on Cloud AI platform. And we can do this through the prediction API. So for example, here we have a flower and we have a prediction for that flower, but we can also see some pixels highlighted. So the pixels highlighted suggest that these are the pixels in the image that made the model give out the prediction that it has given. These are the pixels that contributed or signaled the most towards the model prediction. And at the same time, the instance level attribution is also integrated in what if tool, and we'll talk about what if tool is. So before that, how explanations work on AI platform: you build a model in image, in text, or tabular, and you build a TensorFlow model, and then you deploy that on your AI platform via Google Cloud or through an API. And then now you can use explainable AI directly in your notebooks. And you can also use the what if tool. So you can debug your model in a notebook using attributions from AI platform. So AI platform will return you explainable AI results and directly in your notebook, and you can use them to analyze your model performance. So at the back of explainable AI, it uses different methods to understand feature importances in the model, to understand which pixels are contributing the most, which words are contributing the most in text, etc. for each of the different instances and data points in your data set, right? And some of these methods are integrated gradients and sampled cheaply. Explainable AI overall is inspired by how game theory works, where you have different where you have a team of players and they have a single goal, and but all of those players are contributing differently towards that goal. And explainable AI basically uses that inspiration, and it figures out which features are contributing most towards the goal, and the goal is prediction, the right prediction. So some of these methods are more important, are better in performance. For example, integrated gradients is better in case of image data or text data, and sample shapely and integrated gradients both can be used for tabular data types. And when you're deploying your explainable models on AI platform, this is how it would look like. So I can run this in Google Colab. After I've trained my model, I can basically use this command and deploy my model on AI platform. So I can give it the TensorFlow version, the Python version, and if I'm using explainable AI, then I would also give it the explanation method that I want to use. So in this case, it's integrated gradient, so you would pass integrated gradients. And then you can use another command to basically get results for explanations from the model. So for example, we are building a tabular model for predicting bike trip duration. So given data on a bike trip, and we have features such as start time, day of the week, distance, we also have weather data for a given day. So we want to predict trip duration. So this demo, so this is what the data would look like. You have a lot of features here. and then you have what you want to predict, which is the duration. So you would prepare the model for explanations, the required files that you need, you would send them in. There's one file that's required, which is explanation metadata, which basically gives where you're sending the data, you're also telling your output variable, and you're giving the baseline score. So the baseline score for tabular data, there's a baseline score which against which basically the model understands feature importances. We'll see how baselines work in just a while. So you can see here that we have feature values, and the highest feature value means that this feature is contributing the most towards prediction. So distance in this case is contributing the most towards the trip duration. And negative attributions mean that this feature pushed our model's prediction duration down, and vice versa. It had a negative impact on the prediction, or it had a positive impact on the prediction. So a small quick note on baseline. So when we talk about attribution values, they are relative to something. So in this case, they are relative to our model's baseline. So the questions that you start to ask are, okay, why did X happen, right? Why did it predicted as a cat, right? Or why did the model say this is a cat? Or why did I get rejected from this loan? And why did this transaction get flagged as fraud? But when baselines enter into the picture, the questions change to why did X happen instead of Y? And in this case, Y is your baseline. And why did this transaction get flagged as fraud? Basically then becomes, why did this transaction get flagged as fraud instead of non-fraud? And the non-fraud is basically your baseline in this case. So here we can see that we have a baseline here, which is 13.61. So for all the predictions that the model would make, what Explainable AI would do is that it would give an explanation of why anything apart from 13.61 is predicted, right? So in this case, if the predicted duration is 10.71, then here is an explanation of why it is 10.71 and not the baseline that you set, which is 13.61, right? And then here it's giving us attribution values, which are telling us that what caused it to move down from 13.61, what had a positive impact and was pushing it upwards. And all of these combined then give you the output 10.71. So this is what if tool looks like. Explainable AI also has a what if tool. This you can integrate directly into your Colab as well. You can pip install a what if tool widget, and then you can pass your model into it, and you will get a similar UI. So it has three main parts: data point editor, performance and features, and features. The data point editor is where you can select any data point and you would get all of the feature values here. You can edit any of the feature values, and you can predict to see how changing those feature values is going to change the predictions. And so basically you create this hypothetical situation by changing the feature values, and then you see how the model would perform on this new a piece of data point, basically, hypothetically, that you have created. So what if tool is available on TensorBoard. It's also available, you can directly have it installed in Google Colab as well. You can also use it in Jupyter Notebooks or Cloud AI Platform Notebooks. You can use it for fairness measures, partial dependent plots, explore counterfactuals, threshold simulation. You can also compare two models together, and you can get data set summary. So there are a lot of features available in the what if tool. So the what if tool has extra features which are only for Explainable AI. So if you have Explainable AI, if you're using Explainable AI also in your model and you're passing that information to, so you can pass that information to your what if tool, and it would give you an additional column which will be the attribution values. So attribution values for each instance or each data point, they would give you the importance of that feature for the and its contribution importance contribution towards the model prediction. So whatever the model predicted, it would, for each of the features, it would give out how important that feature has been in this particular prediction. And you can change these values to see how the importance changes and how the prediction also changes. So building an image model for flower classification. So we're predicting, if we're predicting flower type. So here, what explanation does is that it returns the top 60% of the pixels that signal your model's prediction. And for this model, we are using explanations to debug the model and to ensure that, for example, it's picking out the right shapes. So for example, in this case, we want to be sure that we want to verify that the model is picking out the oval shape in the tulips. And in, for example, if it was picking out, or it was the highlighted pixels were in the background and not on the tulips, then we would know that the model is not performing well on. And why is the model not performing well? Because it's not learning the right shapes, it's not learning the right features from the images. And it could be because of any cause, right? It could be because there's class imbalance. In that case, you can have more images for tulip, or it could be because the quality of the images isn't nice, and you can change that as well. So all of the information and the feedback that you get from Explainable AI, you can use that and analyze that to basically make important decisions for model improvement. So to summarize, Explainable AI can help you explain why an individual data point received a prediction, to debug odd behavior from a model. This is as I shared the example of doctor annotations being learned by the model, and the model giving high accuracy as a result. You can refine a model or data collection process. You can verify that the model's behavior is acceptable. For example, you can use the images of flowers and Explainable AI on them to understand that the model is looking at the right features. It's learning the right differentiating features from the different flowers. And you can present a summary of the model. That's about it. Thank you so much. And thank you, team, for having me here. Please, if there are any questions, feel free to ask. And if you want to see some of my work, you can go to GitHub Aqsa-K, and on Twitter, you can find me as Aqsa_K6. And you can message me for any queries or questions you may have. Thank you.